welcome to the special Engineering Outreach Edition, Part 3 of the Art of Engineering podcast. I'm your host, Chad Harden, structural engineer in Irvine with Michael Baker International. You can visit us online at www.taepodcast.com. This show explores the evolution of a career in engineering and also promotes engineering outreach in STEM or STEAM in schools. The show is also an exploration of the idea that artistic and engineering processes are also important as an artistic creation in and of themselves, in addition to the final creation. This week I am proud to present a visit with a local school here in Orange County. In part 1 of the podcast, I talked to the kids about how engineering concepts in different fields overlap, and we do a fun experiment involving an electric guitar and a shake table. In part 2, I answer the kids' questions about engineering. I'll post a video of the experiment on the website. Also, please note this is a live classroom, so some noises are unpredictable, but it will be a lot of fun. I hope you enjoy it.
That's why I give her 2 snaps.
Yeah.
This is my brother Chad. Chad is my second youngest brother. We have Danny, but it goes me, Danny, Chad, and then Allison. Chad is the one who I told you, he and my brother Danny, they used to like play swords, and they were always getting into mischief when we were little. Okay, give him 2 snaps. So he is the one, when you listen to the Art of Engineering, that was Chad's voice. This is Chad. Chad is an engineer. He went to UCI over in Irvine. He was also the one who played football. And then he has 3 girls, and those are my nieces. And there is Charlotte, Tammy, and Vivian. And they are all smart girls who all love engineering stuff too. Okay, so Chad came all the way this morning. He didn't go to work this morning. So I want you, if you need to, you can turn your chair a little bit. You're going to stand on your desk, or you can sit backwards in your chair. And you're going to turn your eyes onto Chad. Okay, give me a quiet coyote on 5, 4, 3, 2, 1. Okay, so I'm going to let Chad start talking. You are going to use every best manner in your body right now. Okay? All right. Go ahead, Mr. Chadley.
Thank you. Thank you all. It seems like this is such a wonderful classroom. I wanted to start by finding out a little bit more about you, and my sister was telling me a little bit about your STEM project. And I thought maybe just by raising a couple hands, you can tell me a little bit about what you've been doing. Yeah.
For our STEM project, we've been working on we made a bridge out of Google Classroom, and we did questions for you.
Cool. I can't wait to answer them. All right. You got a question?
I was going to say the same thing too.
Tell me a little bit more about the bridges that you've been doing on the computer.
Some of us did the Golden Gate Bridge. We got them from. We got pictures from Google and we tried to copy it.
Nice.
We used shapes I did a cylinder for the bottom of it, and then I did a rectangle.
Okay, cool.
Some of us went on images to cartoon people and
A little more.
to put them on the bridge.
Yeah,
Oh, cool. Very cool.
So some people like me, I used a blueprint. I tried to copy it the best I could. The suspenders from the huge tower, and I used a bridge, and I also used a picture of water at the bottom.
Awesome. Any other shapes that you guys used in your designs?
Instead of shapes, there wasn't any round shapes, so I had to use string, curvy string, so then I used string to go around.
Cool.
I used some squares
Okay.
to make it look like it's holding a bridge.
Cool. Good.
I used some circles.
Circles. All right. Well, thank you. Oh, one more in the back.
I used rectangles for the top of the body.
Nice. Well, everything you guys are doing is a lot like what I do. As you know, I'm a bridge engineer, and so shapes are really important to building things because we're building real things and they take shape. And that's geometry. So you'll learn, maybe if not now, later, a little bit about that. Shapes are really important in the design when we get into the structural design, but also the visual part is really important. So there's bridge engineers but there's also architects that do buildings and bridges and how things look. And then we do concepts where you're putting people into the pictures. So kind of what you're doing now is what people do for a job. So if you love a piece of what you're doing, always follow that, which you're enjoying. And then you said you were using blueprints, which is really cool.
Yeah.
And one thing about engineering or anything in general is we're always learning from people that have come before us. So we don't just start from scratch. We learn in school, but then even more importantly, you also learn from older engineers or older scientists or whoever you're working for. And not just in engineering, but any profession. You're going to learn from people that have come before you and have been doing this for years and years. So thank you so much. So we'll dive into a little bit more about that. So I thought today what we do is I wanted to find out a little bit about you, then we're going to do a little bit of an experiment, and then we'll answer some of the questions that you have. So to find out a little more about engineering, we're going to get away from bridge engineering because that's what I do and I love that, but I want you to find out a little bit more about all of engineering. And so to do that, we're going to talk about something you might not expect. I want to talk about waves, and you'll see why that might be important later. So who can tell me in your life, do you know anything about waves? Yeah.
They're usually in the water at beaches.
Great. So water. Okay.
Use your loud and proud voice when you answer chat. Okay?
Sound waves. Awesome.
Use your loud voice, guys, please.
Sound waves.
Like when, kind of like this, like when there's an earthquake in the water, it creates a tsunami.
Right? Ah, that's really good. That's combining a couple things. You've got an earthquake, which is a wave in the ground. And then the earthquake causes a wave in the water. So back to that one.
Okay.
That's really good. Yeah.
Heat waves,
Heat waves. Wow, that's really good.
like from the sun. The sun gives off radiation, which is also another form of a wave.
Right. Wow, you guys are fantastic.
Yeah, well, I'll wheel it out to them.
I think you guys could probably just step right into college next year.
Yeah.
No.
You guys are so smart. Yeah,
Tectonic plates.
tectonic plates, that's right. So earthquakes are caused by tectonic movement in the tectonic plates, which causes the ground to move and move almost like a spring, and that causes the vibrations. You guys are so amazing. One more.
A heavy rainstorm.
Heavy rainstorm. I think you're right. Because rainstorms come in cycles, right? So cycles, kind of like a wave patterns. So there's so many disciplines of engineering and jobs that are out there that all kind of overlap for this idea of wave. So water in the ocean is kind of like oceanography, and there's all kinds of studies of that. We've got sound waves, like acoustic engineers, earthquake waves, so building engineers, bridge engineers have to know about that. Seismic, geoseismic, so people that just study ground. Geotechnical engineering, they have to understand waves. Heat and radiation probably falls under, and the rainstorms falls under like meteorology, so how the climate works. Also astrophysics. There's a couple other ones I want to introduce you. You guys have covered so many. That's awesome. One other thing, even as a bigger picture, even our universe has waves. This is a picture that they think kind of our universe looks like. And actually they figured out it actually has a wave in it. So everything has waves. And the experiment we have today shows how waves all work together. So actually a guitar string, when it's vibrating, is what they call a standing wave. So it starts out like a line, and then we pluck the string, and it can do that, back and forth, or it can do kind of like that, back and forth. And then in electric guitar, the electricity is created by the string moving across a magnet, which creates electricity, which goes into this amp. And electricity, they think, is a wave also. So, when you get into physics later, just an electron is either a particle or a wave, depending on how you're looking at it. So electricity is a wave, goes into this amp, which creates sound, which you pointed out is a wave. And then finally, in this experiment, what we're going to do, we're going to place some songs, and that's going to drive the shake table, which is a wave, just like in the ground. And then that's going to cause this little building to move, which is a wave. So that's one thing that's really important with building engineering, with structural engineering. Just like that guitar string, you have a building, and the building can move, and they call it the natural frequency. It's kind of like how does it move back and forth. And what do you notice about ocean waves? Kind of something interesting about ocean waves.
They move like.
Right. And then if you throw a rock in a pond, or maybe two rocks in a pond, what happens?
Oh, the waves go together and they collide.
Right, the
And
wave
goes up.
collides. And so when you have two small waves come together, it creates a bigger one, right? Or if you have two waves going in the opposite direction, then you get no wave. Right? So just like that, just that simple concept is a lot of building engineering. So if you have a ground wave that's moving in the same frequency as how the building wants to move, that's actually the worst thing that can happen. But what we do is we design the building so that that's not a problem. But that's kind of an important concept about how all these disciplines overlap. After we do this, I'm going to have you guys build your own little buildings. We're going to test those too. But I wanted to first show you how this works.
Whoa. Isn't they ever do it? And move.
Oh, so let me introduce you to my guitar. This is Blueberry Midnight.
Nice to meet you.
Is it should we cover our ears? Whoa! Yeah, it's gonna be loud.
Okay, so watch what happens to the building here.
It's not even loud. I thought it was loud. Oh, that's so cool.
So what happened?
It's
It just kept shaking, right?
Yeah.
So we can say that the building, the way the building wants to move, is not the same as the way the earthquake is moving. So they're out of frequency. So one way to make sure that it is in frequency, which is the opposite of what I would normally do, right? We're going to make the frequency of the building wave the same as the frequency of the earthquake. So they're like two waves coming together. Now let's see what happens. I forgot the most important part. I didn't hit go. I made it so heavy, it's really, really weak now.
Oh.
That's going to happen, right? All right.
No.
Okay, so now we're going to have you guys do your own.
Yeah.
Before we, I just wanted to give you a couple examples of things that I've done. And again, thinking about the shapes. So this is a bridge, and maybe similar to some of the ones you sent me. I did not. This is a prefabricated one. They built this in a shop.
It looks like a train bridge.
It does look like a train bridge. You might be right. Anyway, there's triangles here, right? It's actually one of the strongest shapes. It's not the most flexible. So a lot of times in buildings, they don't use triangles because it's not as flexible. It really depends on what's going on in the building. This is another conveyor. I actually did do this one. This is a bridge for aggregate, so for materials, not for people. And this is crosses also the U.S.-Mexico border. And there's a building here that is built that way, but with triangles, and then this truss. So that was really fun. And it also has cables. Some of you had to sign the cable stayed bridge.
That car right there looks like a parking tower for cars.
Yeah, you're right. This is a rest stop. Again, there's triangles, but there's also rectangles. You can see all kinds of shapes. It's a retaining wall, so a lot of things we design you actually may not notice because they get buried either underground or they're holding up things. You might be living up here in this building and you don't ever see the retaining wall, but it's kind of an important feature. It doesn't always get
That
noticed.
looks like a dam, so there won't be a flood.
What's that?
It looks like a dam.
Yeah, dams are built very similarly also. This is something that gets buried underground. A lot of reinforcing that goes inside the concrete.
We watched that. We watched the bridge being built. We watched how they built the pylon. And they started underground and then how they moved the mold up
Right.
to make the pylon bigger.
That's actually it's like this, the pylon.
Yeah.
Huge reinforcing case that's just taller than a person, maybe 2 people. Oh, this is another conveyor or another aggregation processor in a bunch of braced frames. It has to be really strong because the equipment moves back and forth really hard, and that's like a fabrication design, so mechanical engineering.
It looks like something that NASA would make.
Yeah, right, for the rocket ship platforms. And then just another buried structure, concrete walls. This is kind of like, maybe like what you might build if when you test the Lego. I have some Legos too. If you make like a wall, like this is a really strong in this direction, not very strong in this direction. So you need walls on all 4 sides of the building to hold it up.
I see a lot of these here.
All right, so I have different, this is me kind of fun because I have different materials that's going to be forcing you to build it a certain way, but you can still use your creativity to design within whatever I give you. So we're going to let's make 6 groups. So actually you already have 6 tables. So perfect.
I have 7, but I'll just farm out for a few kids. Okay.
At this point, we are starting the shake table experiment. There were 6 groups and we tested all the kids' structures. Each team had different materials, such as flexible tubes, Legos, and a Connect set. And we shake all of them on the shake table using an electric guitar. There isn't time in the podcast to hear the students' reactions to all the testing, but I am playing the first one for you now. It is always interesting because each building was unique. Each team has a novel solution to the challenge and materials at hand. And that is probably why I love being an engineer and why I love engineering outreach, because even as children, each of us has the creativity and the drive to overcome challenges, which is one of the most interesting and intriguing facets of the human condition. This is probably the highest artistic expression or communication, whether art in engineering or otherwise, which is hope for the future.
Now, what Chad is going to do is he's going to hook up set each design on the shake table. Now, you need to be watching to see whether yours withstands the fall. Okay, are you guys ready?
This is our first building. What I like about this, one, it's a moment frame type building, so it's made out of squares. But I really like this kind of architectural space that we have built into it. It's really, really interesting. So we'll see how that works with the earthquake. All right.
Okay, how pop?
So it's pretty strong, right, for that earthquake? Again, just like the first building we used. But now let's see what happens if we change the way that it moves by adding this.
Okay. Now, what was he using to add mass? What was he using? Who remembers from before? Washers. Is that what you're using?
That's what I'm using.
Okay.
Yep.
Okay.
It's gonna break.
Let's see.
I can really stand with
So the mass is that we're adding the weight, and that's important because it changes the natural wave of the building. It's important. So the strength of the members, but also how much it weighs, changes how
Okay. Hands, and eyes. So the mass changed. Here we go. I'm moving.
Oh, I already broke on the bottom.
Yeah.
So what's different? It's moving a little more, I think.
Yes, it's still surviving. It's moving. Oh my gosh. It's already gone.
But it still stands up.
No! Oh, there's another piece left. This is okay. So it's torture.
It's moving a lot more, isn't it? So it broke.
Yes! Still standing.
So this is really important because this is exactly how we design buildings. It broke a little bit, but what happened? It didn't fall down. So that's super important. And it was in harmony with the earthquake. So it's two waves acting together, but again, it didn't fall down. So and this was a really flexible structure. Let's see what a stiffer structure looks like. Something that moves less. You want to pick or not? You can just strike the strings. It's okay. So it's another stiff building. A lot of architectural stuff going on. So let's see how it goes. Okay, here we go. You can do this hard if you want. Sometimes it's
Listen, do a long one.
that's good. Yeah, just like that.
Do another one.
Not too hard.
Super talented.
Okay. Chad's gonna add something.
That's a 13. How come no one else got that? Because ours is really strong.
Oh, I see something with this wall here.
Uh-oh.
Yeah, just like that. Just like
Because
that.
ours is really strong. Imagine if he adds a bit. Because ours is really strong.
Nice. So this little wall was kind of moving a little bit, which is an important thing. We usually have to tie the corners of the buildings together because we don't want that specifically to happen. So really good job.
Five. You know what? I'm not gonna let anybody. If you all are not on your bottom, then you do not have a quiet coyote.
He's gonna carry it.
5. First of all, that was very exciting. I want you to give Chad 2 snaps in the class.
in my binder.
No, sweetheart, your binder got messed up from a chair. I was watching it. Okay, now turn and look at Chad with a quiet body. Tell me one thing that happened that you didn't think that was going to happen. Tell him one thing. Raise your hand.
I thought ours was gonna fall.
Right?
Yeah, because it didn't look like it had like protection.
That was one of the wheels?
Yeah.
Right.
But we thought it was gonna.
So the movement, is it good or bad? Cool. Yeah, good.
I don't know. I thought that ours it was gonna break a little, but it didn't. It
Right.
was holding it stuff like that.
All of them did really amazing that they broke, but then they stayed standing. So that's the whole idea. Yeah.
I thought that it was gonna break because we made it like a whistle,
Uh-huh.
and it was the weight was more on one side than the other, so I
Right.
thought it was gonna fall over.
Right, right. Yeah,
I thought it was gonna roll off the table.
right, right.
I thought it was gonna fall since the movement of the vibration.
Mm-hmm. Right, right.
I thought it would break because of the movement of the table and all the weight on it. I thought it was just a lot of pieces were going to break that time, but only one snapped off.
It's pretty amazing how much things can move and shift and still stand up. Yeah.
I thought all of them were gonna fall down, you know how fire burns wood?
Uh-huh.
I thought it was gonna go down and break, kind of like a volcano burning a house, or like in Minecraft, fire burning a house.
Yeah, right, right. Yeah, fire has the same effect in that it takes away some of the members, just like when the thing breaks from the earthquake, and then it gets a little weaker and a little weaker. Last one.
Yeah. I thought when we did the wheel one, cause it kept the where the wheels were, it kept a bit moving.
Mm.
I thought when I was gonna go on it, it went so fast. I thought it was gonna roll off and go out,
Right, right.
but because it changed so quick, when it went like this, it changed.
Okay, okay.
It went
Yeah,
back.
yeah. Last one. Yeah.
I thought that the pegs would fall off because of the way they're tossed.
Right, right. No, very, very fun. Very cool. Good
Okay,
insights.
so I have a question. for Chad. Are you ready? Chad, it was, they did not believe me. But I was telling them, I said, you got to ask my brother, ready? Which superhero is the greatest, according to you? They didn't believe me. I said, Chad is a Marvel fan. He likes comics and other things. Who's your favorite?
Incredible.
Yeah?
What's that? I know we're green.
Mine is Spider-Man.
Incredible Hulk.
Incredible Hulk.
I like Batman.
All right. Can all of you give Chad a round of applause? Chad, you've been doing the whole time, and I want you to give a round of applause to my stepmom.
And now, in the second half of this podcast, I get to answer the students' questions. Okay.
Thanks. Fast forward.
All right. So, yeah, ask away. Any questions you have? To the back.
How many times did your boss say you would have to restart?
How many? Yeah, that was a common question. How many times? I would say at the very beginning, when I started engineering, a lot of times I would have to restart. And then as you get more experience, you know kind of what to do, but sometimes you still make mistakes. And I think knowing that you're making a mistake and just saying I'm okay with that, you learn from mistakes. Because if we did things, nobody does things perfect all the time. And it's not a great expectation to say I'm going to do everything perfect. So we know we're going to make mistakes, we learn from them, and we do better. Yeah.
Is it possible to make a bridge like the Golden Gate Bridge out of marshmallows?
Yeah.
Boy, that's a great question. I think if it was deep enough, then maybe, but it would probably be so deep that it would be impractically like tall. It could be like a mile up in the air, maybe. I really don't know. That's a good question.
Do you like making the bridges on the computer or real life bridges more?
I actually, so that's a good question because there's engineers and contractors. The contractor builds the bridge and the engineer designs the bridge, and they're both a lot of fun. I'm not a contractor, but I love designing bridges on the computer. I've always wanted to, when I was a kid, I always wanted to see something on the computer and design it. I think that's a lot of fun.
How many bridges do you build per year?
It takes a long time to build, to design a bridge. It probably takes 2 months for a normal bridge. And a longer bridge takes, like a longer bridge like the Golden Gate, takes half a year to years maybe. So I would say somewhere between, an engineer might design 4 to 10 bridges a year. As a guess.
Wouldn't it be 6 because 12 divided by
That's
2?
right. Divided by 2. Yep. At the best, probably 6 bridges. That's good. Good guess. Yes.
Do you ever get to pick what color it is?
No, I don't get to pick what color
Well,
it is.
if you did, what color would you pick?
Green.
Oh, green. Yeah. But great question, because the visual part of a bridge is just as important, because if a bridge isn't really ugly, let's say, so just somebody doesn't know what they're doing, and
Like brown?
it wouldn't get approved by the people that need to approve the bridges and build them. So the architect, landscape architect, sometimes has a role in how it looks, and that's just as important as the function of the bridge and how safe it is.
What's your favorite bridge you built and why?
The favorite bridge I built might be that conveyor bridge that I showed you, because it was really interesting. It crossed the U.S.-Mexico border. It had to rotate also, so that they can close it off during the daytime. We used an existing aggregate plant. We moved it and used the existing stuff, so that was really interesting. So I'd say that was my favorite so far. Yes?
Do you like the company that you work for?
I really do like the company because they get me. They really like the ideas, like interesting ideas like this podcast, and they like just new ideas. So they're really supportive of that. So finding a company that you like is really important. One that's similar to what you want to do. In whatever field you go in, the culture of the company is just as important as maybe the work that you're doing. Yeah, go ahead.
Do you design buildings?
I have designed buildings. I really like bridges now, but when I started out, I did a lot of different things. I have designed a few buildings, not very tall ones.
How long does it take to build them?
To build a building, probably, I'm guessing about 4 months or so to build it. And depending on how tall it is, it might take half a year or longer, because if you have a skyscraper, that's going to take a lot longer than a house, residential house. In the back, you have a question? Yeah.
If you can make the building or use a different color, what color would you make it?
Green.
Yeah, I don't know. Maybe green, I'd have to say. Yeah.
Golden.
I like actually, you know what I like? There's a certain kind of steel that rusts on we let it rust on purpose, and it creates a protective layer. And so it rusts a little bit, but then it stops rusting and it's protected. Whereas some steel, it's all about how the chemicals in the steel are working. They just continue to rust, and that's bad. But this certain kind of steel, it's called, I think, 410 steel. It builds this like rusty layer, and it looks really pretty. Maybe I would choose that. Yes.
Has it always been your dream to build bridges?
No. I think as you grow up, your dreams change. When I was a kid, I kind of wanted to be either a comedian or an architect. I didn't become either one. I became a bridge engineer. So your ideas change over time. Good.
What's the longest bridge you've built?
Again, that longest one, actually the one I'm working on now is about 500 feet long. So, but it's made out of different, it's not one continuous length. You have a support, and then it goes maybe 30 feet, and then you have another one, and it keeps going like that. So that's a pretty long bridge. Yes.
I actually have two.
Okay.
The first one is, why would you prefer being an engineer to a all-star?
To a
All-star.
Oh, an all-star. That's a great question. That's a great question. I didn't think of that. Well, I think being an all-star would be fun. I like the creative challenge of being an engineer, because I'm always posed with new challenges and I have to overcome creative ideas. That might be the same as being an all-star, but all-star is more physical. So it's just different. But I like the creative challenge. And there's lots of fields that do creative challenges.
And is being an engineer like making a computer or something like that?
Computer science is a big field, and that would be making computers, designing software, which is going to be a really big thing now and in the future with artificial intelligence and how computers can maybe think instead of people and do things on their own and make life easier. So that's going to be a huge field in the future.
Yeah, I want to be a coder when I grow up.
Awesome. Yes.
Out of the bridges that we made, which one was your favorite?
Oh, today?
Yeah, the either one.
Oh boy. I really liked the one with the wheels that moved. I think that was cool. I also really liked the one that kind of moved up with a wave shape to it. And then it's hard to pick a favorite. I like the one that had the moving bell at the bottom, because that was kind of a lot like what they use in tall towers. So they were all really cool. Yes.
Can you make a bridge underwater?
I don't know. What would be crossing it?
I don't know, like maybe like a tube, like going like
They built that before.
like a tube, like cars could go through it. Like
That's a really good idea. There is that, so that would be a tunnel, I think, maybe.
Yeah.
Although actually a tunnel goes underneath the ground, and the ground kind of pushes on the tunnel, and they have to make that strong enough. So I think you could do a tunnel underwater too, because you'd have the same pressure. But in addition to ground, you would have maybe the water movements might push it in a different way too. So it'd be kind of some new challenges. That would be a really interesting way to drive underwater. That's a good idea. That's what's really cool about kids, is you guys are not limited by what you think is possible. And so that's a really great novel idea that I've never heard before. It's really cool. Yes?
Like he said, like it's like the tunnel underwater. You could like make it out of glass, like really strong, like thick. There's
Right.
glass,
Mm-hmm.
so you can see through it and like see like all the different kinds of fish that you've never seen before.
That would be awesome. So not only is the structure design important, but also how are people going to use it? So how, like just in the same thing for a building, when you walk in a building, is it just some walls, or is it like nice glass that you can see through and the light coming through? So that's not only the structural design, but also the architectural design. Yes.
The same thing they're saying right now, couldn't it be like where like you could put like say you need to ship something to like somewhere that you can't really drive, like you have to go on a ship. couldn't you like put something that you need the place it needs to go to, put it in there, and like it will push it to go there without driving. So like it's like a tube, and then like air pushes there. Or something.
Interesting. Yeah, that's a good idea.
It's hard to explain, but
So that's kind of like a new mode of transportation that you're thinking
Yeah.
of.
Yeah.
So there's, I didn't even think about that, but or touch on that. But there's bridges. But then how do people get to the bridge? How do they go from one place to another? All that is transportation engineering. So people have to do models, and actually that's another way. I think in the computer we model is we say, well, there's like 1,000 people that want to go from here to there, but some of the people also want to go here. So there's all these links, and they solve a big model, a big transportation model. How do people go? Where do they want to go? And can they get there? And so that's choosing how big the road should be, where should the roads go. That's a whole field. Yes?
How long have you been building bridges?
I've only been doing bridges for maybe 5 years. But I've been working in structural engineering for 10 or 12 years. Yes, in the back.
How come the Golden Gate Bridge, it's not really painted similar to the name?
That is a great question. Why? Yeah, because it's like painted orange, not gold, right? A lot of bridges are named by the feature that they cross. So the Golden Gate Bridge actually crosses the channel, which is the Golden Gate. So it has nothing to do with the color in that case. But you could name a bridge off the color. Like let's say we had a bridge that was plaid, like all these stripes, you could call it the plaid bridge. I mean, you could do that, but that's a great question. Yes. Yeah.
If you were to work for another job, what would it be?
Yeah, if I was going to start over, and I mean I love doing bridge engineering, but if I was going to say starting today, if I was going to field, I think a really interesting field would be artificial intelligence with computers, or also astrophysics. Have you heard of Neil deGrasse Tyson? He did the Cosmos program on TV. I think it was on Fox. But that is a really fun program. He talks about all of life and physics of how the planets have how they turn and everything related to that. And that's astrophysics. I think that would be really fun. Yes.
I never heard about this crazy bridge in France called the Malau Sky Bridge, and it was like super high up,
Yes.
and it crosses it crosses over a valley.
I have heard. That's a really extremely long and really interesting
Yeah.
bridge.
And also, I have a question.
Okay, maybe one or two more questions. In the back.
I have 2 questions.
Okay.
When they're talking about the glass, like through the water, do you think that would break?
I probably would be kind of nervous about driving in there, but I'm sure that there'd be ways to make sure it was really safe.
And the second question is...
Let's see. I don't think I took a question from you yet. No.
Or college better?
Pro football or college? I probably like college football a little bit.
More off-topic questions, as we call them.
Do you like, what's your favorite ice cream?
Oh boy. Favorite ice cream? What's it called? Moose Tracks? It's like chocolate. Oh no, pistachio is one of my favorites.
I see that one.
Pistachio, and I like.
Chocolate, vanilla,
There's one at 31 flavors that I always
cookies
get.
and cream, birthday,
Gold medal ribbon. Gold medal ribbon.
Yeah!
That's what I like.
All right, now one more silly question.
Okay, go ahead.
What's your favorite restaurant, and do you like grilled cheese?
I like grilled cheese, especially with maybe like a really spicy cheese or Gouda cheese or something. Favorite restaurant? I like my favorite. I think might be Chapter 1 in Santa Ana. It's a fun restaurant. It's got a lot of good food.
All right, can I have the final question?
Sure.
Out of our favorite vacation we took as kids, what was your favorite?
Well, first one that comes to mind that we said that was the Tahoe, going to Lake Tahoe.
That's what I always say. Okay, and the last thing we'd love to know:
Dodgers or
are you Dodgers or
Angels?
bridges like, is it like simple like for you or like?
Right now, it's probably really challenging because I've done a lot of different kinds of things, and now I'm focusing on bridges. So I'm kind of learning again about it. So I think that's one thing that I like about engineering is that you're always learning and you're always challenged.
What's your favorite sport?
Favorite sports? Volleyball.
Oh,
Soccer.
I'm pretty good at soccer. So
baseball.
Yeah, it doesn't mean good at it.
Go ahead.
What do you like to do? What do you like to do in your free time?
In my free time, I like to practice the guitar, and I like to just hang out with the family. I'll go hiking. I like hiking a lot.
I have one question. When you were in high school and you lifted weights, what's the most weight you ever lifted?
Me.
Listen.
I think it was 340 pounds.
That's more than me.
Yeah.
Okay, so the point is, listen, this is the thing that I wanted to share with you. Chad has had a lot of different dreams. He's wanted to be a lot of different things throughout his life. And look at everything he did. He played football, he was a weightlifter, he went to college, he thought he would do something else. Now he builds bridges. And then he said if he could choose it again, he'd maybe choose something else. So Chad is a lifelong learner, and that's the point. The point is to always try new things and to always strive to be something better than you are right this second. Okay, so I would ask him Nope. You give him 2 snaps and a clap. And say thank you. Thank you. Now let him say something.
I want to thank you. You guys were so creative and open to answering questions. You had so many great ideas. So thank you so much for your time, and you guys all have a really bright future. Thank you.
Give him a
Well, that is the end of our show, and a very sweet closing by my sister, who was also awarded Teacher of the Year in her school district. She is an amazing teacher, and I'm so proud of her and all the kids in her class who asked so many great questions. I really am proud of you and all the structures that you built. Well, thank you again for listening to The Art of Engineering. You can find us online at www.taepodcast.com.